practice, amplifier circuits have a very wide range of applications. It can utilize the current control function of the crystal transistor to amplify weak electrical signals to the required value. For example, a common amplifier is a circuit that amplifies a faint sound into a louder one. The sound first passes through a microphone to become a faint electrical signal, then through the amplifier, using the control function of the transistor to convert the energy supplied by the direct current power source into a stronger electrical signal, and it passes through the speaker and the horn to restore it as amplified sound. The teaching objectives of this section are: 1. To master the composition of basic amplifier circuits. 2. Understand the working principle of the emitter amplifier circuit. To understand the working principle of the amplifier, start by discussing the most basic amplifier circuit, taking the common emitter amplifier circuit as an example. In the common emitter single-tip amplifier circuit shown in the figure, an NPN transistor is used. UCC is the direct current power supply for the collector circuit, usually ranging from a few volts to several tens of volts. Its function is to provide the transistor with the appropriate bias, that is, forward bias for the emitter, and reverse bias for the collector, that is, to provide the transistor with a suitable static operating point to ensure the input signal is amplified without distortion. Note that when using a PNP transistor, the direct current power supply should be a negatively polarized power supply UCC. The function of the collector resistor RC is to convert the changes in the transistor's collector current IC into changes in the collector voltage UCE. The resistance value is usually a few thousand ohms. Capacitors C1 and C2 are called direct current blocking capacitors or coupling capacitors. Typically, they range from a few microfarads to several tens of microfarads. Their role in the circuit is to transmit alternative current and block direct current. The function of the base bias resistor RB when the direct current power supply UCC and the values of the transistor UBE are determined by adjusting the resistance value, usually in the range of tens to hundreds of kiloohms, supplies suitable base working current IB to the base, often referred to as bias current, in the circuit shown in the figure. As long as the values of UCC, RB and RC are properly selected, the transistor can operate in the amplification region. Next, let's analyze the working principle of the amplifier circuit. 1. The working condition of the amplifier without signal input. In the common emitter amplifier circuit shown in the figure, when U is 0, due to the action of the base bias resistor RB, the base of the transistor has a forward bias current IB. IB equals UCC minus UBE divided by RB approximately equals UCC divided by RB. For silicon transistors, UBE is about 0. 7V for germanium transistors, UBE is about 0.3V. When UCC is much greater than UBE, ignore. Due to the current amplification effect of the transistor, then the collector current IC equals beta IB. Then the tube voltage drop between the collector and the emitter, UC equals UCC minus IC RC. At this time, the voltage and current in the circuit are all direct current signals. Due to the action of the capacitors C1 and C2, then U are 0. That is, there is no output signal on the load. IB equals UCC minus UBE divided by RB approximately equals UCC divided by RB. 2. The working condition of the amplifier when an alternative current signal is input. When at the input end of the amplifier, a an alternative current signal U is added, the input alternative current signal passes through capacitor C1 and is added to the emitter junction. The voltage UI will act together with the static bias on the emitter junction of the transistor. At this time, the instantaneous voltage of the emitter junction consists of two parts, a fixed and unchanging static voltage voltage B, and a sinusoidally varying alternative current voltage UI. UB equals UBE plus UI. Changes in UB cause changes in IB. The base current consists of two parts, a fixed and unchanging static current IB, and the sinusoidally varying alternative current term KV IB equals IB plus IB. Due to the current amplification effect of the transistor, the collector current will change with the base current, as shown in the figure. IC also consists of two parts, a fixed and unchanging static current IC, and the sinusoidally varying alternative current IC. IC equals IC plus IC. At the same time, IC equals beta IB. When the collector current IC changes, the voltage drop across the collector resistor IC changes accordingly. Since UC equals UCC minus ICRC, when the instantaneous value of IC increases, UCE will decrease. The change in UC is exactly the opposite of IC, as shown in the figure. The change in IC is converted into a voltage change in UCE through RC. UC obviously also consists of two parts, a fixed and changing static to voltage drop UCE, and a sinusoidally varying alternative current to voltage GCE. UC equals UC plus UC. Due to the alternative current passage and direct current isolation of capacitor C2, UC is passed through the coupling capacitor C2. To obtain the output voltage UO by removing the direct current component, then the alternative current part of the two voltage drop UC is the output voltage UO equals UC equals minus ICRC. As long as the circuit parameters are reasonably selected, the change amplitude of UO will be much greater than UI, thus achieving voltage amplification. From the above analysis, we can conclude: 1. The output and input waveforms are the same, but the output voltage amplitude is greater than the input voltage. 2. There is a phase difference between the output and input voltage signals. 3. The essence of the working principle of the amplifier circuit is to use the small signal voltage to control the base currents through the control action of the transistor, then control the collector current by the base current, and form a 2 voltage drop on the collector as the output voltage. The content of this lesson ends here. Goodbye, classmates.